Have you ever looked up on a clear day and wondered why the sky is so perfectly blue? It's one of those things we see every day but rarely stop to question. It feels like the kind of thing we just accept without thinking about it. But the truth behind that beautiful blue sky is actually pretty fascinating and involves a bit of science, a touch of magic, and a whole lot of light. It all starts with sunlight. You might think sunlight is just white, but it's actually made up of all the colors of the rainbow: red, orange, yellow, green, blue, indigo, and violet. Each of these colors travels in waves, but the waves aren't all the same size. Red and orange have longer waves, while blue and violet have shorter, tighter ones. When sunlight reaches Earth's atmosphere, it hits tiny molecules of gas like nitrogen and oxygen. These molecules are way smaller than the wavelength of visible light, which causes something called Rayleigh scattering. This is where the shorter wavelengths, like blue and violet, get scattered in every direction, filling the sky. Longer wavelengths like red and yellow pass through more easily, which is why they don't dominate the sky's color during the day. But wait, if violet light has an even shorter wavelength than blue, why isn't the sky purple? Great question. It turns out our eyes play a big role in how we see the sky's color. Human eyes are more sensitive to blue light than violet, and the sun emits more blue than violet in the visible spectrum. So even though both colors are scattered, blue wins out. As the sun moves lower in the sky during sunrise or sunset, the light has to travel through more of the atmosphere. This extra distance scatters the blue and violet light even more, leaving the longer red, orange, and yellow wavelengths to dominate the horizon. That's why sunsets and sunrises paint the sky with those warm, glowing colors. Cloudy or hazy days look different because water droplets and dust particles are much larger than gas molecules. They scatter light more evenly, which is why the sky can turn white or gray when there's a lot of moisture or pollution in the air. Sometimes, other factors can change the sky's color too. After volcanic eruptions or wildfires, tiny particles in the atmosphere scatter light differently, creating stunning shades of red, orange, and even purple. In places with very clear air, the blue can appear deeper and more vivid. So the next time you're lying on the grass, staring up at that endless blue, remember, it's not just blue for no reason. It's a mix of sunlight, tiny gas molecules, and the way our eyes perceive light. And honestly, knowing the science behind it makes it even more amazing.